Okay, so what I'm going to be focusing on today is actually looking at kind of some different types of clouds that kind of form in different regions, as well as kind of how kind of rain can form or how rain actually will fall, and there's a couple different things that we can do to cause that to happen. So the first thing we're looking at here is simply fog. So a lot of times we consider, think of fog as, during the summer or spring when it's kind of starts warming up, we tend to see fog as kind of basically clouds close to ground level. So it's kind of the air is really thick with moisture, but it's simply they're clouds at ground level. So our clouds are very, very close to the surface. This normally happens is, when we have a lot of moisture in the air and it gets cool at night, we tend to see those clouds form or that fog form very quickly. And then as the sun comes out, you can see it'll begin to evaporate, and the clouds actually break apart and evaporate into the sky due to the sun's heat. Okay. So with advection fog, so like this, when we see like coastlines, you can see off the coast of Oregon here, cold ocean current cools the air, so the air's temperature is cooler. So that cooling creates this fog. So it's normally as that cooler air, air comes in off of that cold ocean current, we create fog, and this will be a type or a special type of called advection fog. Then we have the radiation fog that's kind of more in our area. Again, warm water is evaporating into cool air. So we have this warm water, and as like I said, as the sun heats up the water throughout the day, right, the water will evaporate, and then it hits the cool air where it condenses very quickly. And a lot of times over lakes and rivers and streams or ponds, we see fog forming, right, because we have that kind of radiation or that condensation creates fog. So we call that radiation fog, and it's due to the heat of the sun. Remember, it's one of those ways in which the atmosphere can be heated is through radiation. So that radiation of sunlight is heating up the water in the lake. And the lake will then water evaporates and it condenses when it hits the cooler air. That normally happens either like in the mornings or at night is when we kind of see this fog forming more commonly. Contrails are fairly common now, especially when we see, as we see planes flying over. Not as much right now because the amount of plane traffic due to the COVID virus is decreased. But contrails are normally what we see is they're clouds formed that, we have the water vapor condenses around particles. So basically as the smoke or the fuel comes off of the exhaust of the airplane, there's little tiny particles that the water vapor can attach to. So basically you can kind of see down here, you have the aerosol or the exhaust, right? We have these little sulfur particles, these little tiny particles, they condense, turn to ice, and they produce contrails. So you can see when they kind of form very thick, we can see exactly where the exhaust trail is. That's why I call them trails, because they're trails that kind of follow the plane. So you can see a lot of times with weather maps, we can actually see exactly where planes are flying when we have a lot of moisture high in the atmosphere, because those contrails form very easily. A lot of times they can hang around for longer periods of times, so it kind of depends on the weather conditions for that. Okay, and then we're looking at how basically precipitation forms. There's a couple of different methods. So one thing that we have is we call orographic lifting. Basically it's a change in elevation. So we see a lot of times on mountain ranges is we have a green side of the mountains and a dry side or a rocky side. So basically what's happening is this condensing water vapor, so as these clouds are approaching the mountain, they're going to get forced upwards. So as they move higher in the atmosphere, they're going to get colder, which means there's going to be more condensation. Eventually that condensation is going to cause those particles to get big enough for them to fall. The problem is they will all fall on kind of one side of the mountain, so by the time they get to the top, they're out of moisture, and then what we get dry descending air. So a lot of times in mountain ranges we'll see one side that is kind of green and kind of lush, and it's due to that kind of all that water forming, whereas the other side tends to be very, very dry, right, because all the rain falls on the opposite side of the mountain. So again, it's kind of orographic, so we kind of look at the topography of the land, right, it's forcing the air up. And we get, like I say, we get the green side of the mountain as well as the dry side. Okay. Looking at cloud seeding, so there are ways in which we can cause rain to form. So cloud seeding is basically it's a form of weather modification where we can change it, or we attempt to change the type of precipitation. And so what we do is we normally will add particles into the clouds or into the atmosphere, right, to increase basically the size of the particles. Right, so you tend to increase precipitation, but hail and fog suppression are also widely practiced. So with cloud seeding, basically we're putting small particles into these clouds or into the atmosphere to get the basically water droplets to form larger, right, to cause them to drop their contents. So a lot of times we can do the cloud seeding in order to create the clouds and as well as cause them to release moisture into the air or onto the ground. Okay. And again, the last main thing here is what we're doing is we're trying to get these what we call coalescing, which basically means is to grow into one body. So we have our kind of our water droplets. Initially what they do is they are all very, very tiny little individual pieces of water vapor. Then over time what they do is they begin colliding with each other and then they coalesce. So what they'll do is they'll become larger and larger until eventually they get heavy enough to drop and fall, and as they fall through the sky, they'll continue like basically collecting more and more moisture, right? So they get larger and larger. And this is why we can kind of see different sizes of rain that fall. Normally, the more time or the longer the distance they fall, the larger the drops are. When we have very low clouds, they tend to be kind of smaller droplets because they simply don't have time to collect the moisture. It also has to do with basically, the gravity or kind of the weather and the winds can affect that as well. But coalescing is just simply those water droplets collecting together and eventually getting large enough where gravity pulls them to the surface. Okay? So that's kind of what we have for clouds. Again, once you have finished watching this, you'll be able to go through and answer the cloud questions in the cloud worksheet. And if you have any questions, let me know. You can email me, and I can kind of help you guide you along with anything you need. All right, have a good day.